Very good morning, my dear students. Can you hear me?
Yes, sir.
And what about the presentation slide? Is it visible for everybody? Slide is visible? My presentation slide is visible?
Not yet.
Not yet? Is it my presentation slides are visible?
Now it's visible.
Yes, sir. Now visible.
Okay.
Now it's visible.
Right. Okay. Let us start the class. So in the last class, I think we just started with the concept of a stress, and also I just discussed some of the mechanical properties of materials. We discussed the definitions of different mechanical properties, just like a strength or a elasticity, plasticity, as well as the toughness, resilience, malleability, ductility. Like that, there was almost 10 to 11 mechanical properties we discussed in the last class, right? And also, I think at the end, I think I just given a definition of a stress, and also what is the SI unit of a stress. Okay. For just a minute, we will just recall the things what we discussed in the last class. We defined at the end, we discussed what is a stress. Basically, a stress is the force of resistance a body will offer against a deformation. In the sense, whenever a body is being subjected for an external loading, the body will offer, the material of a body will offer a resistance to undergo a deformation. So that resistance will come in the form of a force. So that force of resistance that a body will offer against to undergo a deformation, we call that as a stress. So stress is basically, it is induced within the material, right? And when you want to calculate the stress, or we generally, the calculation of a stress can always been represented in the form of magnitude of a stress or intensity of a stress, or simply we call that as a stress. Okay. So stress is mathematically we can be expressed in the form of the ratio of applied load or a force to its cross-sectional area, right? So we denote the stress by a letter called sigma, and the SI unit of a stress is Newton per millimeter square or Newton per meter square. Anything we can use. So as we go for higher orders of stresses, the SI unit may be in the form of a kilopascals or megapascals or gigapascals. Anything can be used. And I think I just stopped at 1 megapascal is equal to 1 Newton per millimeter square. Am I right? So this is what we just covered in the last class. So let us continue with the things where we stopped in the last class, right? So in today's class, we will just move on to the next one, what we call it as a types of stresses. See, generally, we have 3 types of stresses to discuss. One is called a normal stress, second one is called a shear stress, and third one is called a bearing stress. Okay. So what is a normal stress, and what is a shear stress, and what is a bearing stress? So this is what we'll go to discuss. Of course, a normal stress are of 2 types. One is a tensile stress, another one is called a compressive stress. Okay. So what actually you mean by the word normal stress? So I think in the last class, we discussed the 2 important terminology. One is called a prismatic bar, another one is called an axial force. So we have defined what is a prismatic bar. A prismatic bar is a structural member which is having a uniform cross section throughout its length. And next is axial force. Axial force is the one which is acting along the axis of the member. So these are the 2 important terms I think I have discussed in the previous class. So now taking the same 2 words here, so we will go to define what is a normal stress. A normal stress is a stress that occurs when a member is loaded by an axial force. So generally, the stress which is induced across the normal section of a member. Normal section in the sense, the section you are going to take exactly perpendicular to the axis of the member. So that is what we call it as the normal, right? So when you say a section is normal, so exactly to that section, the normal stress which will go into be acting, which will be induced within the material of a member, we generally term it as a normal stress. Okay, the section will be always a cross section. So for that cross section, exactly perpendicular to that cross section, if the stresses are induced, then such type of stresses we call it as a normal stress, normal to the section. Remember always, normal to the section. Normal means it will be perpendicular to the section over which you are analyzing or determining the stress. So that is what we call it as a normal stress. So basically the normal stress always induced within the material when it is been subjected for an axial force. In the sense, when the force acting on a member is in the axial direction, and the section what you will going to consider. Okay, so if the stress will act exactly perpendicular to that selected or to the section what you have chosen, so that stress what we generally call it as a normal stress, right? So a normal stress can be either tensile or compressive in nature, depending upon the type of load that the member is subjected for, right? So now, I hope you understood what is the definition of a normal stress. A normal stress is the one that occurs in a member when it is loaded by an axial force. The stress which is normal to the section, that is what we generally have to remember in your mind, right? Such type of stresses, we call it as a normal stress. So normal stress are of two types, or it might be of either a tensile or compressive in nature. So what you mean by a tensile stress? See, tensile stress nothing but, before understanding what is tensile stress, we should understand what is tensile loading. When do we say a member is under a tensile load? So when a member or a body is subjected for two equal and opposite forces which are acting away from each other. Please remember this. Two equal and opposite forces or loads which are acting away from each other along the centroidal axis of the member, then we say the member is under a tensile load. Okay, a tensile load, nothing but, when you we say a member is subjected for tensile load, means when the member is subjected for a two equal and opposite. Two equal in the sense they are equal in magnitude, but they are opposite in direction. Equal in magnitude and opposite in direction. Two equal and opposite forces acting along the centroidal axis away from each other. Both will be acting away from, the direction will be they are acting in the away from each other. Then the body is said to be under a tensile loading. Under such conditions or under such loading, the stresses induced within a member, we call that as a tensile stress. Tensile stress induces when a body is subjected to a tensile load. In the sense, it is a load is acting in such a way that it tends to extend the material in the direction of the application of a load, is called a tensile load, and the corresponding stress is called a tensile stress. Got it? So understanding a load, tensile load, is very important. So the stress which is corresponding to this tensile load or the member, then we will call that as a tensile stress, right? The effect of tensile load or a tensile stress is to extend or to stretch or to increase the length of a member. Okay, so when a body is subjected for a tensile load, so the body gets elongated, it's stretched, or its length will going to be increased. When the length increases, so you have to remember that which is being accompanied with decrease in the lateral dimensions. So decrease in the lateral dimension in the sense, if you take a simple example, a circular rod, A circular rod subjected for a tensile load. So generally we understand it undergoes an increase in the length. The length of the member or a rod will go into increase. So, but the volume, in order to maintain or in order to have the volume to be constant, the increase in length needs to be compensated with a decrease in some other dimension. Please remember. So finally, we have to maintain or we have to have the volume remains constant, right? So therefore, when the length increases, automatically its lateral dimension, that is the diameter is a lateral dimension, diameter will go into decrease. Okay, in the case of a member subjected for a tensile load, length increases, whereas its longitude, where its lateral dimension, where it is in the case of a circular, it is a diameter, or whether it might be a rectangular bar, it might be width and the thickness. So both those things will go into be decreases. So longitudinal, that is length is longitudinal direction, and the remaining other dimensions will be lateral dimension. Okay, this is what we call it as a tensile stress or the effect of a tensile loading. Right. The next comes second one, what we call it as a compressive stress. So it is just a quite converse of tensile loading. So here what happens, just a minute. So here what happens means the body, when it is being subjected for it, as first we will define what is a compressive load. Then we will go into define what is compressive stress and what is the effect of a compressive stress for a load, right? So two equal and opposite forces, you can see here, two equal and opposite forces which are acting along the centroidal axis of the member or a centroidal axis of the body, which are acting towards each other. So look at the direction in which the loads or the forces are acting. Two equal and opposite forces acting towards each other along the centroidal axis of a member, then it is said to be a compressive load. It is said to be a compressive load, and the member is said to be under a compressive loading. Okay, two equal and opposite forces acting towards each other. If you look at the direction in which these arrows are directed here, so look at here. So these two forces are acting towards each other, right? So then, of course, they are acting along the centroidal axis or axis. We can put it in the simple way. We can call it as an axis of a member. Then that type of load, we call it as a compressive load. And the body we said to be, or a member is said to be under a compressive loading. And the corresponding stress induced in the member is called a compressive stress. Got it? So when two equal and opposite forces acting towards each other along the centroidal axis of a member said to be a compressive load, and the corresponding stress is said to be a compressive stress. And the member under such type of loading, we call that as a compressive member is under a compressive loading, right? So now what is the effect of compressive loading? So the effect of compressive loading is to contract or to shorten the length of the member. So just imagine, so when you just compress, when you just apply the two forces acting towards each other, definitely the length of the member will going to be decreased. Or we can put it in the form of the member shortens in its length. Member shortens in its length. So when the length shortens, to compensate for the volume change, so the change in or decrease in the length, so its lateral dimension should increase. So totally a converse of the effect of a tensile loading over here. In the case of a tensile load, length increases, whereas its lateral dimensions will going to be decreased. Whereas in the case of a compressive loading, length will be decreased, whereas the lateral dimensions will going to be increased. Please remember what is the effect of tensile load and what is the effect of compressive load. So tensile load will elongates or stretches the member, whereas the compressive load will always contracts or shortens the member. So this you have to be remembered, right? So now generally, because in order to differentiate whether the member is subjected for a compressive stress or a tensile stress, so generally we have a common practice to use a sign convention. So generally these normal stresses, the sign convention will be always we take tensile stresses as positive and compressive stresses as negative. Please remember this. So throughout our discussion, either it is in a mechanics of materials or any design, wherever you go, so whenever you find a normal stresses, the tensile stresses will be taken as a positive stresses, whereas compressive stresses are negative. Even when you do a problem and when you get a value of a normal stress as negative, it is understood that it is a compressive in nature. Okay, and if you get a positive value, it is understood it is a tensile in nature. Got it? So any clarification, my dear students, regarding a normal stress, types of normal stresses? One is a tensile stress, another one is a compressive stress. So if you have any clarification, so before I just proceed to the next type of stresses. Any clarification from anybody? Definition of a normal stress, tensile stress, compressive stress, and the effect of those normal stresses. Yeah. Any clarification from anybody?
No, sir.
Right. Okay. Let us continue with the next concept over here, which is a shear stress. So we discussed a normal stress as a one which is the stress which will be acting due to the axial forces, the forces which are acting along the axis of the member. The next step is the shear stress. What actually you mean by a shear stress? Shear stress is a force that causes two contacting parts or layers to slide upon each other in the opposite direction. The stress induced or developed across the contacting surfaces is known as a shear stress. In the sense, the shear, before we discuss what is a shear stress, we had to discuss what is a shear load or a tangential load. See, the load which is acting along the tangential direction, not in the axis, tangentially. So that will causes the sliding of one layer over the other. The sliding in the sense when a topmost layer of a member is being displaced to the maximum extent, whereas the succeeding layers below that will be subjected for a smaller displacements. So we can see over here the two plates over here. So these two are bonded together and you are applying a force in the tangential direction. The stress which is the induced across the contacting surface, the two contacting surface or layers slides over each other in the opposite direction. So when you just one layer will slide over the another one layer, so then across these surfaces, the stresses which will be induced, we call that as a shear stress. It is a tangential stress or the load which is acting across in the tangential direction. Then such type of load, we call it as a shear load or a shear force. And the effect of the shear force is to make the layers to slide one over the other in the opposite direction. So when you look at the diagram over here, so this diagram here, so what's happening is, see, this is a one part and this is another one part. Okay, so you are applying a force F in this direction and the below is subjected for another one direction when these two members are bonded together. So because of the load, what happens? The member will be, the sliding will going to be taking place. Sliding in the sense, so one layer over the other, the sliding will going to takes place, and that across the surface, the stresses will be induced because of that what we call it as the resistance that the surface will going to offer to make that layers to deform. So that resistance will be induced in the form of a stress. So that resistance, the force of resistance across the layers of the member, okay, we call that as a shear stress. So shear stress is usually denoted by a letter called tau. Tau, you can see this is tau. It is a shearing force by shearing area. So this is a different. The normal stress is the cross-sectional area. Here is a shearing area. So when it comes, I will go to explain how to differentiate cross-sectional area with the shearing area later, right? But the stress is, again, it is a shear stress is represented by a tau throughout our mechanics of materials. We use the letter called tau as a shear stress, and it is the ratio of shearing force. P is the shearing force divided by the shearing area. So of course the SI unit will be remain same as a Newton per millimeter square. So this is what we call it as shear stress, right? Then the third type of stress what I wanted to discuss is a bearing stress. A bearing stress is a localized compressive stress at the surface of contact between the two members of a machine part that are relatively at rest, is known as the bearing stress or a crushing stress. So a localized compressive stress at the surface of contact of the two members between the two members of a machine part that are relatively at rest is known as bearing stress or a crushing stress. You can see here is the two plates are fastened together by using a bolt and a nut. Okay, and these plates are subjected for the load P in the shown direction here. Okay, so here what happens, the bearing stress is the one when you just apply a load here, the bolt is a stationary, am I right? Bolt is remains stationary, and when you apply a load in this direction across the surface of contact between the two members, okay, so the type of stress that will be induced, the force of resistance that the body will go into offer to undergo a deformation or a failure is induced in the form of a stress. That type of stress we call it as a bearing stress. Okay, so bearing stress is nothing but that, again, it is a load by area, where area will be calculated as thickness of the plate multiplied by the diameter of the bolt. Okay, this is the diameter of the bolt, will have a diameter, and this is the thickness of the plate. So we're going to say bearing area. Bearing area is T into D. So this is how we will go into calculate the bearing stress. Okay, so different ways in which we need to calculate the stresses, taking out different areas or different cross-sectional areas or shearing area, or sometimes we need to take the bearing areas, crushing areas, then such type of stresses where the compressive stresses across the surface of the contact between the two members of a machine part that are at relatively relatively rest is known as bearing stress or a crushing stress. So please remember normal stress, shear stress, and bearing stresses, right? Next comes we were talking about a stress. We defined what is a stress, what is the types of stresses, normal stress, shear stress, and a bearing stress. And even under a normal stress, we have discussed two types. One is called the tensile stress, another one is a compressive stress. So next comes a strain. What actually we are defining about? So one of the most main objective of mechanics of materials is to determine the stresses, strains, and the deformation. So we discussed what is a stress. So it is a force of resistance offered by a body against a deformation or to undergo a deformation, right? So now Next comes the word strain, because when the member is subjected for external loading, definitely it undergoes a deformation. Because we are in the first class, I mean second class, I just explained we are discussing only a deformable bodies. So in the sense, when the body is subjected for an external system of external forces, the body will undergo a deformation. So deformation might be in the form of a change in size as well as in the change in shape. So now how do you express or how do you determine how much amount of deformation that the body has undergone? So that amount of deformation that the body will undergo when a body is subjected for external loading can be expressed by using a term called a strain, right? So now let us define what is a strain and what are the different, how we express the strain annotations, and what is the unit of a stress, and what are the different types of, different types of strains, right? So when a body is subjected to some external force, there is some changes in the dimensions of the body. So that is what, of course, so one important thing what you're supposed to remember here is, of course, the body, if you say a deformation. So throughout our discussion of a mechanics of materials, so we are intended to understand that deformation means the change in size. Of course, change in shape also occurs, but our scope will be change in the size of the member. So therefore, whenever we say deformation or a deflection, there will be a change in the dimensions of a body, right? So therefore, when a body is subjected to an external force, there is some change in the dimensions of the body. So the ratio of change in dimensions of a body to the original dimensions is known as strain. Please remember, a strain is the measure of the deformation. So any body, of course, all we will say body means it is deformable body. You should remember always, when a body is subjected for an system of external forces, it undergoes a change in the dimensions of the body. So how much amount of change it has undergone? So, and that amount can be calculated or it can be expressed in the form of a term called a strain, right? So now let us define what is a strain. A strain is the ratio of change in dimensions of a body to the original dimensions of the body. So mathematically, we can express it as a strain as the ratio of change in dimension to the original dimension. And we usually denote a strain by a letter called epsilon. Okay, please remember these annotations are very, very, very important. So because you should remember what is sigma, what is tau, what is strain. So how we will go to express or how we will go to denote these mm, terms with annotations. These things are very important. So stress is expressed as a sigma, whereas the shear stress is expressed in terms of tau, whereas the strain will be expressed in terms of, or it will be denoted by a letter called an epsilon. Okay, a strain is a change in dimension to the original dimension. See, this dimension why I'm talking here is a dimension may be anything. So whether the dimension may be corresponding to a length, or it might be a diameter, or it might be a width, or it might be a thickness, anything it can corresponding to. So that dimension is the change in dimension, how much amount of the change that dimension will undergo to its what is the original dimension. That ratio between the change in the dimension to the original dimension, we call that as a strain. So simple example, if I say when a body is subjected for a tensile load, so the effect of tensile load is what? To increase the length of a body. So how do we calculate the tensile strain? So of course, I'm going to discuss those things later part. So if the strain is occurring along the axial direction, so we generally term it as an axial strain. Okay. So this dimension might be a length or a diameter, width, thickness, anything you can show. So whenever we want to calculate the particular strain in the direction, so you can change the dimension by that particular dimension. Whether it is a length, it will become change in length to the original length. If it comes diameter, change in diameter to the original diameter. Like that, we can keep on changing the dimension depending upon which direction we supposed to, or along which side we supposed to determine the strain. Then coming to the unit of a strain, so since it is a ratio of the dimensions only, so generally dimensions will be expressed in either in millimeters or meters. So the ratio of millimeter by millimeter or meter by meter, so it will constitutes, there is no unit for a strain. A strain is dimensionless. Strain is dimensionless. It does not have any units. So if you say what is the strain, you will say around 5 into 10 power of minus 6. That's it. So there is no Newton, there is no meter, there is no millimeter, nothing. Nothing should be given. So strain is a dimensionless entity or a quantity. It does not have any units. Please remember, because it is the ratio of the dimensions. Got it? Now, next comes types of strains. So we have a linear strain, lateral strain, shear strain, and volumetric strain. Okay. So linear strain, again, there are two types: tensile strain and compressive strain. Then lateral strain, we have shear strain as well as the volumetric strain. Let's start with what is a linear strain. So look at here, a linear strain. A straight bar will change in length when loaded axially, becoming longer when in tension and shorter when it is in compression. This change in dimensions in axial direction known as linear strain. In the sense, if a member is subjected for a tensile load or a compressive load, as already I have discussed in the previous slides, the effect of tensile stress is to increase or to stretch or to elongate the member, whereas the effect of a compressive stress or a compressive load is to shorten or contract the member. So the deformation, if it is taking place, if the change in the dimensions are taking along the direction, along the axial direction of the member, then such type of strain, we call that as a linear strain. The change in dimensions in the axial direction is known as linear strain. In the sense, so when the member is subjected for a tension, the length will increases along the axial direction, whereas if subjected for a compression, the length will decreases along the axial direction. So such type of strain, we call it as the linear strain, right? So here, the diagram what we are showing here, a straight bar, a prismatic bar, which is subjected for a tensile load F, and its original length is F, and due to the application of a tensile load, its length has been increased by an amount of dl. The amount of increase in the length is taking place as dl. Original length was L, right? So now, since the loading is taking place in the tensile direction or in the tensile nature, so the corresponding strain also said to be a tensile strain. So if the load is tensile load, the strain is also said to be a tensile strain. So tensile strain is the change in length. Change in length. So of course you can write it as, because it is a tensile strain, we can put that as an increase in length also can be put. Okay. Change in length to the original length. So how much amount of change in length in this case? It is a dl by L. dl by L. So means in the case of a tensile loading, length will be increases. So therefore you can write it as increase in length to the original length. That can also be, that's why we have put here extension. Change in length, in this case it is an extension because it is a tensile strain, and we can write that is in the mathematically as dl by L. Okay, this is a tensile strain. Next comes compressive strain. Look at here, the member as prismatic bar is subjected for a compressive loads, two equal and opposite forces acting towards each other. Look at the direction of the force F. So because of course its original length was L, And because of the application of a compressive load, length will be decreased by an amount dl, right? So the change in the length is taking place along the axis of the member. So that's why we term it as a linear strain, or we can term it as an axial strain also. Not wrong in that, right? So since the type of load is a compressive load, the nature of stress that will be induced will also be a compressive in nature. So that corresponding strain, we call it as a compressive strain. So the compressive strain can be expressed as change in length to the original length. So change in length is reduction or reduction in the length, or the length of the member will be shortened, right? So again, dl by l. So mathematically, we are expressing a compressive strain as a decrease in length to the original length. Decrease in length or reduction or shortening, all are same. So reduction or change in, or a decrease in length to the original length, we call it as dl by l. So these are the two types of axial normal strains or axial strains or linear strains, we can call it as. And next comes lateral strain. What actually we mean by a lateral strain? I was talking in the previous slide. When the length increases, in the case of a member subjected for a tensile load, its lateral dimensions will be gets decreased. Lateral dimensions will gets decreased. So in the sense, the changes in the dimension will also takes place in all the three mutually perpendicular directions. If the load acting is along the axis, so whether it is a tensile in nature or compressive in nature, the change in the dimension or a deformation will also takes place along the direction in which the force will act, as well as simultaneously the direction perpendicular to the direction in which the forces will act. There also the changes in the dimension will go to take it as. The direction in which the force will act, we call it as a longitudinal direction or axial direction. And if it is perpendicular to the axis, we call it as a lateral direction. Okay. So when a member is subjected for a normal load or an axial load, so you will be going to, a member will going to experience the deformation both longitudinally as well as laterally. Longitudinally as well as laterally. So what we discussed in the previous slides, just like the tensile strain or a compressive strain, they are acting or they are occurring along the length. So that is acting along the axis of the member. So we generally term that as a longitudinal strain or an axial strain, whatever it might be. Now we have to concentrate on what about the dimensions which are perpendicular to the length or perpendicular to the axis. So those dimensions, we call it as lateral dimensions. So in that respect, so whenever a member subjected for an axial load, so the change in the dimensions that takes place laterally. Laterally means exactly perpendicular to the axis of the member. So that deformation can be expressed by using a term called lateral strain. So lateral strain is also known as transverse strain, which takes place at right angles to the direction of the applied load, is known as a lateral strain. See, look at here. So the loads are acting along the axis over P here, and the strain is exactly perpendicular, which is at right angles to the axis, where the length is increasing here, where the diameter is decreasing here. So the diameter will be considered as a lateral dimension, where length is the longitudinal dimension or a linear dimension. Okay, so the strain which is exactly perpendicular to the applied load, then that change in the dimension, we call that as the lateral dimensions or lateral change in the lateral dimensions, or we could express it in the form of a lateral strain. Okay, this is a very important thing. So that's what I was talking about in the previous slides. Due to an tensile load, length will increases, whereas lateral dimension diameter will go into decrease in the case of a rod having a circular cross section. Conversely, if a circular rod subjected for a compressive loading, the length will go into decrease, whereas its lateral dimension diameter will go into be increase. So the change in the dimensions both longitudinally as well as laterally, we can express it in terms of a strain. So this is what we are talking about, a lateral strain over here. Okay. This time I will just discuss one important thing here, and afterwards I will go back. So next comes Poisson's ratio. I wanted to discuss this now. Poisson's ratio. See, Poisson's ratio is one of the most important material property. So I will come back to this shear strain and volumetric strain to next class. Now I want to discuss what is Poisson's ratio. So once we understand what is a lateral strain and a linear strain or a longitudinal strain, so the next term important thing is the Poisson's ratio. So we define a Poisson's ratio as a ratio of lateral strain to the linear strain. So I was talking about when a member is subjected for an axial loading, so it experiences two types of strain. One is along laterally, or one is along longitudinally or in the linear direction, and another one along the direction perpendicular to the axis, what we call it as a lateral strain. So now the relationship existing between the longitudinal strain or a linear strain with the lateral strain is in terms of a term called a Poisson's ratio. A Poisson's ratio is the ratio of lateral strain to the linear strain. Please remember, this is a very important definition. Many times it has been asked in your exam. Define Poisson's ratio. Poisson's ratio is the ratio of lateral strain to the linear strain. So we can say we're going to express the Poisson's ratio either by using a term mu, or we can use nu. Nu is also another one term what we will going to use. So nu or mu, anything you can use. Okay. Yeah. So Poisson's ratio is the ratio of a lateral strain to the linear strain. Yeah. So we can get the ratio in terms of the lateral strain to the linear strain. Epsilon lateral is a lateral strain, and this is linear strain. We can use mu or nu. Nu is also another one term which has been used to denote the Poisson's ratio. Okay, so look at here. So this is the linear strain which is taking place along the longitudinal direction or linear direction, and this is the lateral strain. The term which relates lateral strain to the linear strain is nothing but the Poisson's ratio. So Poisson's ratio is the ratio of lateral strain to the linear strain. It is a ratio of two strains. Okay, and since it is a ratio of strains, it does not have any units. So we'll say the Poisson's ratio as simply it is a 0.5, 0.9, 0.5, 0.3, 0.2, like that we're going to express. So even though the strain does not have any units, in the similar way, the Poisson's ratio does not have any units, but it has got a vital role to play in our mechanics of materials. Okay, this is a Poisson's ratio mu, and of course we can use another one. Got it? So this is nu is also another one symbol which is used to express the Poisson's ratio. Got it? So now at this point I will going to stop. So if you have any clarification, my dear students, you can have. So if you don't, if you after clarification, you can go back, switch on to the Google Classroom for attending a quiz. Any clarification, my dear students? Any point starting from normal stress, strain, and the definition of Poisson's ratio?
Sir,
Yeah.
sir, can you just present the bending stress slide?
Bending, not bending, bearing.
Bearings, yeah, bearing stress slide, yes.
Yeah, sure. Yeah. Yeah, tell me.
Sir, I didn't write the formula, that's why.
Okay, it is P by T into D.
Sir, here it is assumed that the bolt itself doesn't undergo any stresses, right?
No, not stresses. It is stationary.
Yeah, like the plank, I mean, the two bodies which are colored in
Yeah,
orange, they will undergo the
yeah,
stress. And what
yes,
about the bolt
definitely.
itself? The
No,
bolt
bolt will
itself
also,
is
bolt
rigid.
is under, no. Please understand here. It is relatively at rest. The machine part here, what we have taken, it is a bolt here.
Okay.
Okay, so two
Yeah.
plates are there. Okay,
Hmm.
so when you apply a force in this direction,
Yeah.
so this bolt will be get subjected. It will go into be displaced. The air, sorry, that layers are there. No, the bolt will go into be
Yeah.
moved along the plates only. So stress will be the
Behave
bearing
like
stress.
a steering thing machine for
So,
the bolt.
sorry,
The bolt,
sorry.
the metallic bolt, it will behave like as if it is under shearing stress, right?
Definitely,
Because
definite shearing stresses will take place with the plates. But what happens
okay,
in the case of a bolt will be a bearing stress, because we're going to calculate stress with the bear in the bolt machine part in the form of a bearing stress, not in the form of a shear stress.
oh, okay, yeah,
Got it?
understood.
Yeah,
Yeah,
got it.
okay,
Yeah,
sir.
yeah. Any clarification, my dear students? You can ask me any doubts, any clarifications if you have. You can stop me. You can just have the clarifications with you. So if you don't have any clarification, I will just move on to the Google Classroom. So attend the quiz over there. Shall we switch on to the Google Classroom?
Yes, sir.
Yeah.
Yes.
Yes. I will just assign the quiz over there. Yeah. So you can attend the quiz. Yeah, switch out to the Google Classroom. Quiz 3, it is assigned to you.
Sir, if we are done with the quiz,
Yeah, you can leave.
can we?
If you don't have any clarification, you can leave.
Thank you, sir.
Right.
Excuse me, sir.
Yeah.
Sir, which book do you suggest for practicing numericals and all?
You have Strength of Materials by SS Bhavikati.
No, sir. Actually, we are not in Bangalore, so we won't get all those local author books. Sir,
No,
any
no.
standard
You can-
author? If
You
sir,
can
SS Bhavikatti is not available over here.
online.
No,
Okay.
sir.
Better you check for Strength of Materials by SS Ratan.
Yes, sir. SS Ratan is available. Is that
Yeah.
good book, sir?
Yeah, very good book. Very good book.
Okay. Okay, sir.
No problem.
Thank you, sir.
Right.